So today we will start with the next are the functions. So we have done till squeeze. So we will do from joining arrays today. So first concatenate. So I just imported pandas and numpys over here. So the first one, let me consider two arrays. So I say x is equal to np dot array 1, 2, 3. Excuse me. Y is equal to np dot array 5, 6, 7. Excuse me. Z is equal to np dot concatenate x comma y. Print z. So concatenates both the things. Similarly, when you are having multidimensional also 1, 2, 3, 4. Similarly, 5, 6, 7, 8. So 1, 2, see one below another you would be getting. But for suppose if I say the same thing, comma, axis is equal to 0, axis 0 also would be same. But if I say, comma, axis is equal to 1, you get in the horizontal way. All the first elements 1, 2, 5, 6 in one row and 3, 4, 7, 8 in another row. Got it? These are basically the concatenate functions. Next, you have is stack. So stacking. So basically, stack function returns the stack array with one or more dimensions depending upon the input. So suppose I say the same thing I consider in place of this concatenate, I'm just removing this function so-called concatenate and I'm just keeping stack. So 1, 2, 3, 4 and 5, 6, 7, 8 in another thing. Suppose I say you have this in place of concatenate if I keep stack. So it says 1, 2, 5, 6. Vertically the first element and 3, 4, 7, 8. If suppose I say axis is 0, it prints like the normal stack. See, axis is 0 and the normal stack behaves the same. But what about single dimension stack like this? If suppose I consider this one. You are working on a multi-dimensional, right? What about the single dimensional? It prints one below the other. So here, can we do comma? Axis is equal to 1. It prints 1, 5. That means the first column prints as the row. 2, 6 and 3, 7. If suppose I say axis is 0. It prints one below the other. This is stacking. Next, horizontal stack. See, when you stack, normally we are just stacking. If suppose I say hit stack, horizontally it gets stacked. Mm, for this multi-dimensional also, if you consider hit stack, 1, 2, 5, 6 and 3, 4, 7, 8 will be printed. Now, let me say A is equal to np dot array 1, comma 2, comma 3, comma 4. Let me print A first, and I consider B is equal to np dot array 5, 6, 7, 8 and print B. And I consider C is equal to np dot hit stack, considering A comma B. So it prints 1, 2, 3, 4 and 5, 6, 7, 8 separately, and the way you are printing the same way, even though you consider separately, it prints the same thing. But how do you stack when you are having two different dimensions? Suppose I say np.array, it's 1, 2, 3, and this is 4, 5, 6. This is, I consider, only 7, 8. So once you print these things, I consider x is equal to np.array 7, 8. I am considering dot reshape -1, comma 1. Y is equal to np dot hit stack, horizontal stack, considering A, comma x. Print Y. So it prints 1, 2, 3, and then it prints 7 in the first row. 4, 5, 6, and then it prints 8. In this way, it gets stacks. This is about horizontal stacking. Now you have vertical stack. In place of hit stack, V stack. One below the other, it prints. Suppose I say 1, 2, 3, 5, 6, 7, 4, 8, 9. If this is the thing, sorry, V stack. It prints 1, 2, 3, and then 5, 6, 7, and then 4, 8, 9. That's it. Vertical stacking is only this much. Then you have D stack. What is a D stack? Diagonal stack. So, or else generally it's rather than depth-wise stack. So, D stacked is something. Let me consider these two arrays. NP dot D stack. Both array 1, comma array 2. That means the x, comma y. It prints 1, 2. That means vertically you would be getting 2, 6, and 3, 7. When you are having multidimensional, so it prints 1, 5, 2, 6, 3, 7. Similarly, 7, 3, 8, 4, and 9, 1. So this is D stack. See, for each and everything on the stacks or concatenation, I'm just telling one on the single dimensional, and the second one I'm just telling on the multidimensional. Don't forget that. So we have done concatenate, stacking arrays, vertical stack, horizontal stack, depth stack, and then you have split. Suppose I say A is equal to np dot array 10, 20, 30, 40, 50, 60. B is equal to np dot split A, 3. Print B. So it prints in three different splits: 10, 20 one part, 30, 40 another part, and 50, 60 another part. So if suppose I say I wanted to do some array split, so np dot array underscore split A, 3. Even though the values are not like, if there are no equal halves also, it do. The last part, it prints only one, if you observe. The next one, suppose I consider an array. I wanted to do vertical split. For me, the array should be multidimensional. np dot array 1, 2, 3, 4, 5, 6, 7, 8. Vertical split 2. So rather than, you can see array 1, 2, 3, 4, one array, 5, 6, 7, 8 another array. Next one, horizontal split. Horizontal split, the data should be in the form of A is equal to np dot array 1, 2, 3, 4, comma 5, 6, 7, 8. So you get 1, 2, 5, 6 one part and 3, 4, 7, 8 one part. So when you are considering the data will be like this. So this one part and this one part, it gets splitted. Horizontally, it splits. Next one is again a D-split. Suppose A is equal to NP dot A range. Let me consider some 24 values and I say reshape. If you observe, when we are doing all these things, yesterday's functions are also again coming. Let me print A first. So this is an array. So B is equal to NP dot D split A comma 3. See, without you giving print, you get one below the other. So it prints 0, 1, 6, 7, one part. Similarly, this together one. Again, mm, 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 mm. This one part, this another part, and this one another part. This is the thing. So I think so joining arrays and splitting arrays was done. Now we have to do some mathematical operations. So when coming to mathematical operations, there are multiple different mathematical operations. Not all we work on with. We just go on with few things, maximum to maximum. So let me say, let me consider X and Y are these arrays. Print np dot add X comma Y. Subtract multiply divide floor division floor divide power X comma 2 mod X divided by 4. So it always gives you the remainder mod. Similarly, you have remainder function also. Print np dot reciprocal. It reciprocates. print np dot square. Let me do with x. It reciprocates. You are having multiple different things over here. All these values, it's reciprocating. See, rather than working on with these functions like this, what you can do is, you can directly do x plus y, x minus y, x into y, x divided by y, x floor division y. You can use the symbols also. That doesn't mean that you are not supposed to use the symbols. There are functions. That is the reason we are working on with those functions. X power y, x greater than y, x less than y, x equal to y. Any of these things also you can do. So x is this. Suppose I say print np dot cbrt cube root x. Suppose I consider a is equal to np dot array minus 10, 20, minus 30. Print np dot abs of a, absolute value. Sign. If it is negative value, it prints -1. Positive value, it prints 1. If it is 0, it prints 0. Suppose if I say comma 0, comma minus 90. Got it? Next. np dot clip a, comma 15, comma 25. That means the values between 15 to 25 you will be getting. Initially, the value is little smaller. So it considers 15 only. 20, it considers 20. All these values are below 15. So it considers 15 only. I consider a is equal to 5, 6, 7. Print np dot exponential of a, exponential value. Similarly, you would be getting to the base 2. Similarly, you are having log, by default log. Suppose if you wanted to change the base values, log to the base 2. Here I can log to the base 2. What other functions I have? Log to the base 10. Log 1p, 1 percentile. And we have some trigonometric functions also over here. So Log and exponential. Log addition also we can do. So for that, for log addition, you have to take two values. Suppose I say A is equal to 2, B is equal to 3. Print np dot log add exp A comma B. You get the log addition value. Now, all the trigonometric functions. So for trigonometric functions, first I can take the angles. So I consider A is equal to np dot array. I'm taking group of angles. So I say at 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120 and 180. Okay. Now my print np dot sine A. Sine values gets printed. Similarly, see, even if you want for a single angle also we can do. We are doing multiple different angles over here. Tan. Similarly, you have arc sine. Arc cos. Arc tan. That is basically nothing but inverse tangent, inverse cos, inverse sine. Now you have hyperbolic sine. So for hyperbolic sine and all, see hyperbolic, you just add h. You get all the three things. Similarly, you are having degrees. Print np dot degrees of A. Similarly, radians. Similarly, done. Similarly, you have some statistical functions. So, when coming to the statistical functions, we didn't do all the statistics part yet. We will be doing it in our later classes. What is minimum, what is median, what is a... Just for now, just remember all the functions. So here, A is this 0, 30, 45, 60, 90, 120 and 180. Print np dot mean of A. Median. Median is cumulative mean. Then standard deviation. Then you have variance. You have sum. You have product, prod. Suppose if you want the minimum value, min. Maximum value, max. Index of minimum is nothing but argmin. Index of maximum argmax, percentile. So I say A comma 50. It prints 60 is the percentile. Suppose if you want quantile, A comma, I want some 50% value, you have to say 0.50. It gives 60. Now, if I want the average, so it gives the average marks, average of all the angles. Now, let me consider x is equal to np dot array 1, 2, 3, 4, 5. Y is equal to np dot array 2, 4, 6, 8, 10. I say print np dot correlation coefficient of x comma y. Always the correlation lies between -1 or +1. It lies between -1 and 1. Next, so generally normal correlation can't works, but covariance works, COV. Covariance, there is no special thing that you have to, like, it's between 0 and 1 or something like that. It was not there. So we have done this equal to and all, and also two things. Suppose I say, consider two arrays, x greater than y, x less than y. Comparison operators, all the comparison operators you can do. X not equal to y, x greater than equal to y, x less than equal to y, x equal to y. All the 6 comparison operators we have performed. And some searching functions. So suppose I consider A is my array. If these are my values for an array, print np dot where A greater than 100. Wherever the values that are greater than 100, that means this is as per indexing, this is 0, 1, 2, 3, 4, 5, and 6. Those indexes will be printed. So the next one, if I say np dot non-zero, wherever it is not 0 will be printed. So 1, 2, 4, 5, 6. The index positions, it will be printed. So search functions are where and non-zero. Now you have sorting functions. Sorting functions are argsort and partition. So it gives the indexes after sorting. So I consider an array like this. Print np dot arg sort of A. So it prints the smallest one. This is 0, 1, this is 2. So 2, 3, 4, 0, 5, 6, and 1. It gives in the ascending order of the indexes. Got it? So we are having partition. Partition generally in the string functions or in the base Python, we have seen that we have done into two partitions, two parts, right? Here how it works. So let me consider the same array. Print np dot partition a to. So it prints in the, it makes it into two parts. So the first four into one part and so it's generally not so. It always gives you in such a way the smallest three elements are placed in the correct position. The remaining elements may not be fully sorted. So in that way, it actually do. The smallest three elements are 45, 60, and 90. They are placed in the first position. Remaining all, it won't sort perfectly. Suppose if I say 5, even then it's not. Only 2 actually works. So it by default, it sorts the first three smallest elements, 0, 1, 2 indexes. Next one, let me say if this is my array, print np dot unique. You get all the unique elements. Suppose if I say a is equal to np dot array, true, false, true, false, true. If I give group of Boolean values, print np dot all of a. If all are false, then it is false. Any of a. If any one is true, then it is true. So previously, we have done equal to and all using the symbols, no? What if you wanted to do using the function, like equal using equal to function and all? Print np dot equal a comma b. I'm doing all together, not underscore equal. Greater. Greater underscore equal. That means greater than equal. Similarly, less. Next one is less equal. Less underscore equal. Even this 6 functions also we can do. Similarly, print np dot maximum. Maximum value gets printed. Minimum. Minimum value gets printed. So till here we had done. So we have to done with random modules, random module, broadcast, bitwise operators, and missing actually we will be working on with the later part, and string functions. These functions we will see in tomorrow's class. The remaining functions we will be working on with 1, 2. Around some 35 functions are there. These things, if I just tell all together, you would be loaded up or piled up.